Sometimes in this SBA test or any other test, the problem is related to how to prove something that is shown. So in this case, we have this sentence only. So they are assuming that we know how to prove that this is a parallelogram. There is many ways to do it. Well, first of all, we need to understand that a parallelogram has two very important characteristics. Number one, the opposite sides, like this and this side, must be the same length and parallel. That means these sides must have the same slope and the same distance between this point and this B and this C. So proving that, we have half of the work made. The other thing is proving that this segment DC and segment AB are also parallel and the same distance. So we need to show everything, and we are going to start by doing something very important. First of all, we need to understand that the point A is -1 and 4. These are the coordinates. For B, the coordinates are 3, 2. So this is 3 and 2. You remember the x's first. For C, the coordinates is 1 and -6. For D, coordinates are -3 and -4. So -3 in x, -4 in y. So once we have this, we need to find by pairs. I'm gonna find this pair first. I'm gonna find both slope and distance between these points. So first of all, I want to find the slope. So I'm gonna make a slope AD must be equal to slope BC. So this is one of the characteristics of this parallelogram. So first of all, I need to find a slope and slope AD. So my slope AD is gonna be, and always is the same formula. Slope equals y2 minus y1 over x2 minus x1. So in this case, I'm gonna take this x1 and this is gonna be y1. So this is gonna be x2 and this is gonna be y2. So if I mark this, I'm gonna ensure that I'm gonna take the numbers correctly. So this is y2 is -4 minus y1, that is 4, over x2, that is -3, minus x1, that is -1, is -1. So check, we have a double negative over here. So we need to change into a positive. So I can do this. Negative times negative is now positive. So what I need to do now is add numbers on top. This is -8. And the numbers on bottom is -3 plus 1. This is -2. And then I make this division. So negative divided by another negative is positive, and 8 divided by 2 is 4. So this slope is 4. So let's check if this slope is also 4. So this slope BC, equals, and I'm following also this formula, and I'm gonna mark this as x1, y1. Let me mark better. This is y1, so this is x2, and this is y2. So my slope now is y2, which is -6, minus y1, which is 2, over x2, that is 1, minus x1, that is 3. So I'm gonna make this -6 minus 2, this is -8. 1 minus 3, that's -2. Again, negative divided by negative is a positive, and 8 divided by 2 is 4. So in this case, this slope is also 4. So this side and this other side are parallel. So first of all, I understand that these sides are parallel. Now I need to know if this distance AD and distance BC are equal. In this case, I'm gonna find those distance with the following formula. I'm gonna erase this. So formula for distance is distance equals square root. I'm gonna take x2 minus x1 square plus y2 minus y1, and this also square. Let's take first distance AB. So distance distance AD. Distance AD. So this is again my square root, and I'm gonna make x2 is -3 minus x1 is -1, and this goes square, plus y2 now is -4, I'm talking about this, minus y1 that is 4, and this goes square. In this case I have a double negative here. I'm gonna change it to a positive, so this is positive, so this is square root. So -3 plus 1 is -2, this is -2, this goes square, plus -4 minus 4, that's -8, -8, this goes square also. So this distance AD equals square root, this is -2 square is 4, plus -8 square is 64, and I'm gonna only add those numbers. This is square root of 68. I don't need to find the square root because this is a number I can use. So now for distance BC, I'm gonna try to find the distance, and this formula is this distance BC equals square root, again is x2 is 1, minus x1 that is 3, this goes square, plus square root y2 that is -6 minus y1 that is 2, and this goes square also. So in my square root I'm gonna make -2 square plus -8, because this is -6 minus 2, this is -8, this goes square also. So this distance BC equals square root, this is 4 because it's -2 square is -2 times -2, plus -8 square is -8 times -8 is 64, and this, just adding these two numbers, is the square root of 68. So as you can see, this distance and this distance, so this distance is square root of 68, and this distance is also square root of 68. So slope are equal, distance are the same, so I can see this is a parallelogram. Just to be totally sure that this is a parallelogram, I'm gonna make the same for segments AB and DC. So I'm gonna erase all this stuff. This stuff is gonna be erased. So let me clean this a little bit. So I'm gonna find first slope AB. So my slope, let me find the points again just to mark it one more time. So this is -1 and 4. This is 3 and 2. This is 1 and -6. And this is -3 and -4. But now I'm taking these two first, and then these two second. So now I'm gonna make slope AB. So this is x1, y1, x2, y2. So my slope AB equals, you remember, slope is y2 minus y1 over x2 minus x1. So this is y2 is 2 minus y1 that is 4, x2 that is 3 minus x1 that is 1. So this slope is on top. Well, obviously we have a double negative here. This is positive. So on top I have -2. On bottom I have 4. So all this slope is -1/2. So this slope is 1/2. So now let's check slope DC. This slope DC is, this is x1, y1, x2, y2. If you mark this way, you never forget who is who. So here is y2, that is -6, minus y1, that is -4. Don't forget, write this negative sign when you have it. So now x2 is 1 minus x1, that is -3. So you make this positive. Negative times negative is positive. Negative times negative is positive. So now what you have is -6 plus 4, that's -2. 1 plus 3, that's 4. So this is -1/2 again. So this slope and this slope, I'm talking about this slope that is -1/2 and this slope which is -1/2 are the same. The last point I have to prove is this distance are exactly the same. For that, I'm gonna use my formula for distance. This formula is this. Distance is square root x2 minus x1 square plus y2 minus y1, and this goes square also. Let's take AB. So distance AB equals square root. Okay, what is x2? x2 is 3 minus x1, that is -1, goes square, double negative makes positive, plus y2. y2 is 2, as I'm taking this 2, minus y1, that is 4, minus 4, this goes square, so square root, this number is 4, this is 4 square, I'm gonna make in a parenthesis, plus 2 minus 4 is -2, and this is square. So this distance AB, it's 4 square is 16, plus -2 square is 4, is positive because -2 square is -2 times another -2, so negative times negative, that's positive, 2 times 2, that's 4. So here in my square root I have square root of 20, and I don't need to find this square root. My number is square root of 20. So now I'm gonna find the distance DC. So distance DC is square root, and I have x2, which is 1, minus x1, that is -3. This goes square, plus parenthesis now. y2 is -6 minus y1 is -4. -4, it's a double negative. So this is double negative, this goes square. So this square root, this number is 4, this number is 4, and this is square, plus this number is -2, and this goes square also. So this distance is square root 4 square is 16, plus -2 square is again 4, so this is square root of 20. So you need to show all this work that prove that this is a parallelogram. Why? Because this slope DC, it's equals to slope AB, and distance DC is equal to distance AB. And you proved before that this slope and this slope, this distance and this distance are the same, so this is a real parallelogram.